In this video, I'm going to show you how to use a spreadsheet to find the location of the steepest slope of a function. And in this case, we're going to look at the function e to the minus x squared. And we're going to look for the steepest negative slope. This is an even function, and it's sort of a bell-shaped curve. And so we're going to look for the steepest slope to the right of the origin. Okay, so first thing we want to do is define a column of x values and f of x values, and then we're going to have a column also for, we're not going to actually plot the f prime values, we're going to plot an approximation of the f prime values. So I'll put approximate f prime of x. And there's a few ways to do this. One thing that I'm going to want to do is I'm going to want to zoom on different regions. So I don't want to have a fixed list of x values here. I want to be able to modify them. So I'm going to start with an x min written over here. Let's say we'll start at 0, an x max, and we'll start that at, let's say, 4. And now how many cells or how many intervals do I want to break up the interval 0 to 4 into? I'm going to make that 20. So we're going to break it up into 20 slots, or 20 intervals. And how big should each of those intervals be? The delta x should be equal to 4 minus 0 divided by number of steps. So when I put my x values over here, I'm going to start off with the x min value exact, and then I'm going to take that value. So I set for a formula, I start with equals, and I put in a4 and then add to it. Now, if I just were to write f6 here, I would get an increment of 0.2. But you'll notice if I copy that, something weird happens, and that's because if you look up here, f6 in the next row down becomes f7, f8, and there's nothing in those cells down here. The way to get around this is to include that $, which locks down the row and column that we're referring to. And now when I copy this, I will have the correct incrementing. Now I started in cell 4, so I'm going to go to 24, and that means with 21 entries here, I can go all the way from 0 up to 4. That's 20 intervals, or 21 cells to do it. And this cell, we're going to have the exponential function, which we can't write as e to the power in a spreadsheet. It's usually using function notation x of minus. And now instead of writing x, I'm actually going to refer to the value in the neighboring cell. So that's a4, and then square that and close the bracket. So that's the starting point. And to copy, I'm just going to double click on this corner, and it'll automatically copy to the neighboring, anywhere where the neighboring cell has an entry. So that's the f value, and if we wanted, we could plot that. But first, let's get an approximate value for f prime. Now, instead of taking a derivative and plugging that in here, we want to do this all numerically, taking advantage of the spreadsheet's calculations. So what I'm going to do here is I'm going to use secant lines and find the slope of a secant line near 1. Now, one option is to choose this as my f of x plus h, and this is my f of x. But that means that our step size here is going to control the accuracy of our f prime. We want this to be really small, and if we're going to change the viewing window, it's going to make it a little bit unpredictable as to how good the delta x is for a derivative approximation. So I'm going to make a new value h, and h I'm going to make extremely small, and this way WebWork will be happy with my accuracy in the end, and I never have to worry about that value changing. So before I put down an f prime of x column, I'm going to put in an f of x plus h. And now I've separated the increment here for the list purposes with the increment for the secant line purposes. So here I'm going to have f of x plus h is going to be the exponential of minus, and now I have to put these in brackets, squared. And now in those brackets, we will have a4 plus $f$8. And that is the value of f at a very close neighboring point. to x. Okay, so now I can use this entry and this entry to define the slope, or to calculate the slope, approximate slope at x, which is going to be the slope of the secant line. So here I take equal, I need a bracket there, parentheses, so I get f of x plus h minus f of x, all divided by f8. And that is the approximate slope. So I double click on this corner and I copy those all the way down and I get f prime of x. Now I'm actually going to just move this whole block over to give me a little bit more space. And you'll notice even though all of these are now in G instead of F, when you do a copy and paste like that, or a Control X, Control V, all of the references to F8 have now become G8. So the spreadsheet is smart that way when you move things around. Okay, so now I wanted to find the location of the steepest negative slope. Now I wanted to find the location of the steepest negative slope, and I was expecting these to be negative numbers, but I see now there's some errors cropped up. So let's go back and see where that happened. Well, first, you'll notice that this column here is increasing, whereas it should be decreasing. Okay, so there's a parenthesis problem. Okay, I haven't figured this out. For some reason, Google Sheets misinterprets the scope of the squared. And so I have to put parentheses around the x squared part and then put a minus sign in front. And now I think this will fix it. Yeah, now it decreases properly. And now you can see we'll have to do the same thing here. So now I have to put a bracket around here and around the x squared as well. And that should fix the f of x plus h column. Okay, and now we have all these slopes are negative. Okay, so where is the steepest one? Well, it looks like there's a 0.84, 0.83, it looks like it's around here. Now, if you wanted to be sure without having to track all these decimal places, here's a little trick. You'll notice that from here to here, the slope goes down. From here to here, it goes down again, down again. When we hit the maximum, it'll stop going down and start going up again. So here it went down, now it goes up. So what we can do is in this column, we can put in the difference between this one and this one. And if that difference is negative, that means that the f prime column is decreasing. And if it's positive, it means it's increasing. This is partway to writing down the second derivative of f, but I didn't go completely down that road. All I did is I'm seeing what is the difference between these two values. And you can see it negative, 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 so it's decreasing, decreasing, decreasing. And then from here to here it decreased. Then all of a sudden from here to here it increased. So that means that this one right next to the cell after the change is the maximum one. Okay, so that's where we have our steepest negative slope. And so let's just graph this quickly. And I'm actually just going to graph the x and f prime, but I'll delete those middle two from the graph. So now you can see here, I don't want the x as an x series. Let's remove that and let's put it in here as A4 through A24. And now that's the x-axis, and I want to get rid of this one and this, oh, no, this one and this one. And now I just have the derivative. So you can see here, what we just found was that the steepest slope was around 0.8. Now, is the steepest slope right at 0.8? Well, this you can see is a little jagged, and if you were to round it out, it's hard to tell exactly where the steepest slope would be. It may be right at 0.8, but it could be somewhere in between. So all we know is that the slope is biggest somewhere between the 2 points neighboring that location. So what that means is it looks like the steepest slope is at 0.8, but all we can tell is that it's somewhere between 0.6 and 1. So what we can do with this x min and x max is we can go up here and put in 0.6 and here put in 1, and all of a sudden those 3 rows have now been expanded to 20. And now we can look again and see, oh yeah, there's negative, 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 negative. Oh, now it went positive. That means this is the location of the max, at least in this listing. And that means that the max is going to be close to 0.7 and most likely, or certainly between 0.68 and 0.72. So now we put up here 0.68 and 0.72. And now we have a new zoomed in region. And you can see we're still getting a max on the graph down here. And so we can keep doing this. Why do we have to keep doing this? Well, because the interval that we're interested in, if we're going to enter this into WebWork, it has to be more than 2 decimals of accuracy. And because the interval that we're dealing with still goes from 0.706 to 0.71, I need to get closer in so that my first 2 digits, or first 4 digits, are the same in all 3 of these rows. So if I keep on zooming, I'll eventually get to the point where I have good enough accuracy in my X and I can plug it in. If you do that and you find you still don't have the right answer, that probably means that your H value is not small enough. And so you have to go to a smaller value of H. 10 to the minus 11 is probably plenty small for our purposes. Okay, and that's how you use a spreadsheet to find the location of steepest slope.